Human Experience, Chapter 13, Evolution of Civilization. Civilization defined. What does it mean to be civilized? This is another of those terms that have different meanings as technical terms in anthropology than they do in the common vernacular. In general usage, it might be common to say, after emerging from a weekend-long backpacking trip in the wilderness, that one has returned to civilization. In this sense, it might simply mean you have cell phone service again, or that you have access to Burger King has been restored. Or we might refer to someone as being civilized if they are polite, cultured, or treat others with respect. That is, they are civil in their treatment of their fellow humans. While these are laudable traits, this is not what it is meant when we talk about the evolution of civilization. For our purpose here, civilization refers to a set of behaviors that reflect a certain level of social cultural complexity. The defining characteristics of civilization include populations that are sufficiently large and sedentary that they live in a relatively dense concentrations. Some of the settlements would be considered cities, even by modern standards. See figure 13.1. The population is organized according to socioeconomic aspects of behavior. Subsistence is based on food production that is efficient enough to generate a surplus. That surplus is controlled by the elite and invested to create social infrastructure that serves the elite and the general public to varying degrees. The workers not involved in food production are freed up to work as craftsmen, merchants, artists, soldiers, construction workers, etc. Monumental public works such as pyramids, irrigation systems, roads, and monuments serve vital, integral, integrative purposes, both in a practical sense, as with the case of irrigation canals, and at an emotional level, as with public monuments that help establish a sense of nationalism or shared public identity. The organization of society is accomplished through a system of government and the important ideologies, laws, and accounting records are maintained using an official form of record keeping or writing. See figure 13.2. In this chapter, students should gain an understanding of the basic components of civilizations. You should also become familiar with the range of explanations or causes that have been proposed to explain their development. You should learn about some of the reasons that prehistoric and historic civilizations have collapsed, and how that might relate to observations about the behavior of our own society. Why do civilizations develop? The first civilizations rose in the same regions where food production was developed and intensified. Figure 13.3. From this pattern, it is reasonable to infer that food production and therefore larger, more densely concentrated populations were preconditions for the evolution of civilizations. The specific intensification varies from region to region. Therefore, depending on which regions and which civilizations they study, researchers have proposed somewhat different scenarios for how such stratified societies came about. For the purposes of discussion, the most commonly proposed explanations for the development of civilization can be grouped into environmental and cultural factors. A variety of Old World and New World examples of civilization illustrates the role of different potential causal factors. Figure 13.3, regions where many of the civilizations of ancient world evolved. In the early years of anthropology, the development of civilization was often viewed as the inevitable result of a unilineal cultural evolution. It was assumed that cultures evolved through a series of stages involving increasingly complex advances in technology, such as the intensification of agricultural development of metallurgy, etc. Morgan, 1877. Morgan argued that culture moved forward toward civilization as it developed greater complexity. But the idea is circular because it essentially says that civilization happened because it did. Karl Marx proposed an economic-based version of this idea of increasing complexity as agricultural production became intensified. There emerged a division between those who owned the means of production, such as farmland and livestock, and those who did not. As surpluses, wealth, accumulated among the former, the need arose for exchange between the different classes. This need was filled by the development of a new class of full-time merchants. As commerce became increasingly important, government structure and policies were needed to solidify the unequal structure of society. In this view, the main function of government would be to protect the interest of those who control wealth while reinforcing their authority. Environmental influences have also been invoked as explanations for the development of particular societies. Karl Wittfogel suggested that control of water supplies and the need to build water infrastructure such as irrigation systems were the impetus for civilization. In this model, known as the hydraulic hypothesis, it is the need to control and direct a large labor force in the building, maintenance, and operation of irrigation systems that causes society to be reorganized into a ranked society with different social classes. Whoever controls the water can dictate the activities of others, and their power is reflected in the construction of monumental architecture, such as palaces and pyramids. The lower classes must, in some sense, accede to control by the elite in order to benefit from the overall productivity of the system. Here's the picture. The circumscription hypothesis, Canaro, 1977-34, alleges that only coercive force can account for the development of a civilization, not enlightened self-interest. Carnero argues that in areas where resources are limited and population are bound or hemmed in by their neighbors, social responses to population growth are limited. Eventually, such populations, if they are to continue to grow, will expand into the neighboring territories and seize land by force. In other words, competition among neighboring groups resulted in military growth and organization. As civilizations expanded, they absorbed defeat enemy populations, thus accelerating the rate of population growth and the need for further expansion. It should be apparent that the potential causes or traits of civilizations don't occur in the same sequence or in the same combination in all places. Where civilizations developed, for example, population growth and trade, may have been the early catalyst in Egypt, whereas flood control was most important in the Indus Valley, and defensive fortifications were more important in China. The overall constellation of traits end up being similar in different regions, but the history of their development differs from place to place, making it difficult to identify a single cause. Trigger, 2003, identifies two key developments that must occur for civilization to evolve: increasing social complexity and the growth of cultural institutions that manage that complexity. Some of the institutions that appear in most or all civilizations to accomplish the management tasks include kingships, class systems, religion, support of the upper class through the use of force, and control of economic production. I am personally drawn to Jonathan Hass's idea of social integration as a useful way to discuss these various social mechanisms. The social integration model recognizes that different combinations of trade, warfare, irrigation, and population control needs led to the formation of complex societies in different places. The key common element was the need to develop large-scale mechanisms of social integration, that is, ways to control and mobilize large labor forces operating on behalf of the entire entire social integration, that is, ways to control and mobilize labor forces operating on behalf of the entire society, and ways to build the social infrastructure necessary to operate a complex system. The social structure, hierarchies, differential access to goods and services, and eventually the accumulation of what we would call wealth. One of the attractive aspects of the social integration model is that it doesn't matter which driver to integration is most characteristic in particular culture or specific place or time. The pressures on a cultural system to grow and expand include several factors working together and in different combinations in different places. But in the end, the results are more or less the same. Large populations need complex social structures to manage all the parts of society so that the system as a whole can function. Social integration as a route to the evolution of civilization can be viewed as a permutation or a variety of culture change that is predicted by a world systems model. The world systems concept is an approach to studying cultural change in complex social systems. Chase, Dunn, and Hall, 1977. It extends Marxist emphasis on materialism to a consideration of international relations. In its original configuration, the world systems model it was intended to apply to modern market economies. Wallerstein, 1974. However, if one shifts the focus from one modern countries in a global economy to prehistoric societies in regional economies, a quote world economy unquote, perspective can be a useful way to examine prehistoric complex societies. Upham, 1982. A world system model envisions an economic system in which players benefit while others are exploited. If we consider this on a regional prehistoric scale, it could argue that there will be core societies that constitutes the center or hub of regional economic systems, which exploit surrounding peripheral societies for things such as raw materials and exotic artifacts that identify or reinforce elite status in the core societies. Peripheral societies in these regional systems would be dependent on the core societies for capital, organizational knowledge, and perhaps protection from other core societies. Part of the structure of the core society consists of a set of mechanisms that redistribute resources from the undeveloped raw material exporting periphery to the developed, industrialized, or at least civilized core of the system. So the general scenario in the context of a world systems perspectives might be something like this. Population growth leads to agricultural intensification. The investment of more soil, water, or energy per unit of time or area. Intensification leads to additional population growth, environmental degradation, and increased production costs. Rising cost leads to population pressure, leading in turn back to the next cycle in the agricultural trap discussed in the previous chapter. As long as there are suitable lands into which the society can expand, migration will be the result. When there is not an option, warfare is likely outcome. So the major internal, external, and managerial challenges involved several of the regional examples of civilization. Are all accommodated in the world system's view, albeit in different combinations and sequences? Let's consider one additional idea. Societies as systems of energy capture and use this model, developed by archaeologists working on the rise and fall of prehistoric societies in New Mexico, explicitly accounts for not only the rise of complexity, but also cyclic changes and even collapse of complex systems. Stewart and Gunther, 1981. The possible adaptive approaches are conceived as occurring in two dichotomous evolutionary modes or adaptive strategies. Power strategies are characterized by increasing rates of population growth, high levels of overall productivity, and high rates of energy expenditure. Growth in these aspects of society is supported by intensification within this subsistence strategy. In contrast, efficiency strategies exhibit low rates of population growth, production, or energy expenditure. They reflect extensive broad-spectrum adaptations that tend toward the maintenance of homeostasis. This dichotomy is probably overly simplistic in the real world, as most cultural systems fall somewhere along a continuum between the extremes. In this model, hunter-gatherers and other small-scale societies would be at low energy use end of the spectrum. They have relatively small populations, relatively small energy requirements, and large per capita areas of the landscape. Moving toward the other end of the spectrum is representative of a power drive. Population growth is rapid, leading to the formation of large social groups. The labor input devoted to production increases, as does the emphasis on agriculture and the overall amount of energy consumed per capita. Smaller and smaller areas of land are needed per capita because increases in productivity support larger populations in smaller portions of the landscape. What is perhaps most interesting about this model is that it provides a way to think about individual societies or regional populations moving from one part of the continuum to another. In other words, individual systems have the potential to oscillate between power and efficiency drives or poses depending on the circumstances at hand. Intermittent periods of growth or power drives may be interspersed with periods of decline or homeostasis. Carmichael, 1985, 29. Patterns like this have been documented for a number of prehistoric groups, such as the Maya, Diamond, 2005. Periods of growth occurred at some Mayan cities at the expense of their neighbors in the periphery, but during periods of decline, cities in the periphery sometimes entered power phases, thereby overtaking the earlier core settlements in the system. When the system overshoots the carrying capacity of the environment in which it is situated, the entire system may collapse, as in the case of the Mayan Empire. However, in this model, it is possible to conceive of the collapse referring to the world, i.e. regional system, not a biological population. overpopulation, environmental degradation, and warfare all result in real hardships and losses to real human populations. Yet there still are many indigenous Mayans in Mesoamerica. The structure of the Mayan world system collapsed, but the biological population survived, most notably those at the bottom of the social hierarchy, not the elite. Resource intensive adoption, resource intensive adaptation, and modern oil dependency. Societies involved in power strategy are well known to us today. The United States has been in such a growth mode for the past century, and the rates of growth and changes are accelerating from a world systems perspective. Much of the cost of our systems is in acquiring natural resources and transporting them to the system core, the United States. Or if the consumer goods are manufactured elsewhere, the natural resources will go there and the finished goods are then transported to the system core. As indicated in Chapter 12, the cost of transporting food over long distances is one example of this. Another example is the ongoing quest for oil. Most geologists believe we have already reached or will reach the moment of peak oil, the point at which we have already found and extracted half of all available oil supplies. After that point, significant new discoveries will be few, and the remaining oil will be harder to extract and be in greater demand, thereby raising prices. Worldwide oil production is apparently now at or near its peak, and we can expect a downturn in the global availability of oil in the not so distant future. Clare of 2007. We live in a highly stratified hierarchical world in which 1,000 people at the top control assets worth twice that of those held by the bottom, 2.5 billion. The top 10% own 85% of everything. Much of that wealth relates to the control, distribution, and use of oil resources. It is already the case that wars are being fought and about who will have control over the dwindling supply. If our society and our other societies around the world make poor choices about how to address future energy needs, it is possible that we might exceed the carrying capacity of the environment within which we operate. Yes, technological advances might forestall the large fluctuations, at least for a time, but many analysts view our present course of action as unsustainable. Shermer, 2008, argues that in all of human history, there have been about 60 civilizations. The average longevity of those civilizations has been 40 years. Among civilizations that have developed since the time of Christ, the average longevity has been 304 years. Shermer, 2008, page 30. The United States has been in a system for about 240 years. Is the system collapse really on the horizon? We shall see. We do not mean to imply that the ecological or nuclear dooms are inevitable, but we do think they are unacceptably probable. Because of the immense human tragedy that is likely to the world about how the forces of social evolution work, and we must organize the political forces that will try to reform the capitalist world systems in order to prevent these outcomes. But we should also prepare for the possibility that partial dooms may indeed occur, and be ready to reshape the system of survivors into a democratic and collectively rational global commonwealth that will eliminate warfare and poverty, protect the global ecosystem, and regulate population growth at a sustainable level Chase Dunn and Hall of 1997. We will consider a major potential impetus for systematic collapse, global climate change in the final chapter. For now, think about what it would mean to return to an economy without oil, to cycle back to an efficiency trajectory in our adaptive strategy. Author Charles Sullivan, 2007, has written the essay Uncommon Grace, Biology and Economic Theory as a way to think about alternatives, the way it was before and how it could be again. This is the end of chapter 13. Thank you.